rate out problems. This is typically one of the 6 free response questions on the AP exam. You may notice that these free response questions will ask you to find information that pertain to concepts we've previously looked at. Having confidence on solving problems like these can have a significant impact on your AP exam score. So we are going to revisit this when we hit chapter 8 as well. But if we let f of t be the rate that something increases and g of t be the rate that that same thing decreases, then a of t is the total amount of whatever that is at time t. And so the total change is the rate in minus the rate out. And that's actually, if a of t is the total amount, then a prime of t is that total change. Then if we want to find the total amount at time t, given some initial condition, let's go ahead and use our highlighters. This is going to be the critical piece of information. And I lost a little grouping symbol here. Let's put that in as well. A of t, that total amount, is whatever the initial amount is plus, and then that integral represents the accumulated change, and it can be a positive or a negative. So let's go ahead and we're just going to look at multiple free response style questions. This is from 2005, free response question number 2. It says the tide removes sand from sandy Point Beach at a rate modeled by the function r of t. So if you use, that's a rate. It's really important to pay attention to, is the function an amount or is it a rate? And so r of t is a rate and it's removing sand. So we're going to call this a rate out. A pumping station adds sand to the beach at a rate modeled by S of t. So this is the rate in. Both R of t and S of t have units of cubic yards per hour, and t is measured in hours for t is between 0 and 6. At time t equals 0, the beach contains 2,500 cubic yards of sand. In part A, how much sand will the tide remove from the beach during this 6-hour period? So let's read that again. How much sand, so I don't want a rate, I want to know how much sand will the tide remove from the beach during this 6-hour period? So how do you go from a rate to just the amount? What calculus technique do we use? An integral, right? So, and I have it from 0 to 6. And which function represents removing the sand? R of t. Now this is a minimum amount of work. Like you will get a point on a free response. You don't just put an answer. You'd only get 1 out of the 2 points. So now grab your graphing calculators. And I'm going to go ahead and pull mine up. And I want to show you how you do this on the graphing calculator. So this is what we call a calculator active problem. And here's what you're going to do. You open up a blank page. You go to Menu. Okay, you press Menu, Calculus. And then we've already done the numerical derivative at a point, but I don't believe we did the numerical integral yet. So then we're putting 0 to 6. And then you need to type in r of t, which is 2 plus 5. Now, I don't know if this happens on your calculators, but if I do 5 sine, I get an error message. It doesn't like that. So I have to put the times the sine, and then you'll do your 4 pi t. We'll see if that, we might get an error. But we'll see. T divided by 25. Now, I chose the letter T. You could do X instead, but then it has to be DT or DX, depending on which letter you choose. Oh, there, it did it just fine. Can you see that? Okay. So, then let me go back here. So this is 31.816. So I would always answer this in a sentence. The tide will remove 31.816 cubic yards of sand during this 6-hour period. Part B, write an expression for y of t, the total number of cubic yards of sand on the beach at time t. All right, so watch how we're going to do this, and we're using what we highlighted up here. So y of t is going to be the initial amount, which is 2,500, plus, then I'm going to have the integral from 0 to 6, and you're going to do time, or not time, I guess, but rate in minus rate out. So that's going to go S of t. Oh, whoops, wait a minute. Let me change this a moment. They wanted me at time t, sorry. So I'm going to go 0 to t. Now, I cannot add, and I just caught myself. You can't have it go 0 to t and then put S of t and R of t, because then you don't know which t's we're doing. So I am going to just change that to S of x minus R of x dx, because then you're going to put the t in, is where you're going to evaluate it. So there is my expression that would represent the total number of cubic yards of sand on the beach at time t. So then it says, find the rate at which, so now I want a rate at which the total amount of sand on the beach is changing at time t equals 4. So I actually want y prime of 4. So I want to take the derivative of my expression in part B. Well, what's the derivative of a constant? 0. So the derivative of the 2,500 is 0. Then we're going to use the fundamental theorem of calculus. When I take the derivative of an integral, this is going to represent S of 4 minus R of 4. So you're going to need your calculators and go compute S of 4 and R of 4, and then subtract. So let me give you a moment to be able to use your calculators. Have you ever used this, like a store feature, where you could put the expression in and then store different values? I can look for a video on how to do that. I mean, there's no big deal to just plug in 4 and for t. into your S function and your R function. So I got, when I did S of 4 minus R of 4, I got negative 1.909. So it's really, really important that you know how to press the buttons on your calculators, okay? So here's how I would then put this in a sentence. The amount of sand on the beach at t equals 4 hours is decreasing at a rate of 1.909 cubic yards per hour. If you use the word decreasing, you wouldn't put a negative, okay? For letter D, for time between 0 and 6, and notice this is a closed interval, it says at what time t is the amount of sand on the beach a minimum? So I want to know at what time, and then it asks me what is the minimum value. So this is the extreme value theorem, and we have to use the candidates test when you have a closed interval. If it were an open interval, you can use the first or second derivative test. Let me say that again. The first and the second derivative tests are for open intervals. Using extreme value theorem is on a closed interval. So I'm going to need to do y of 0, which we knew was 2,500. We're going to need to do y of 6. And then we do need to find any critical points. And critical points are going to occur where y prime, I don't know why I put a capital T there, where y prime of t would be 0. Well, y prime would be s of t minus r of t. And so this would occur where s of t equals r of t. So if you remember, I've told you that there are 4 reasons to use the graphing calculator on the calculator section. One is a numerical derivative. The second is a numerical integral. The third one is right here, is to find a 0 or intersection. And then 4 is just to be able to look at a graph, like what does it look graphically. So let's go ahead and let me go over on the graphing calculator how you find this intersection. So let me pull my screen up, and we're going to open a graph. So let's put r of t in. And then you're going to put s of t in, but I'm calling it x. And then between 0 and 6, we're looking for the intersection. So you just do menu, analyze, and intersection. So I'm getting 5. Does yours go further than that? I don't know if I have mine rounded, because on mine I had 5.1179. Do you? Okay, cool. Yeah, yeah, okay. So then I've got a critical point that this is occurring at 5.1179. And remember, decimals need to go 3, like at least 3. You can go further, is fine. So then on my candidates test, I check my endpoints and any relative extrema. So then you're going to use your calculator, and my y of 6, remember, and you're going back up to part B where y of t is. That's where you're plugging that in. So then y of 6, I got 2493.2767. And then when I did y of 5.1179, I got 2492.369. So where is the minimum? The minimum amount of sand is 2,492.369 cubic yards at time is 5.1179 hours. And so when they say justify your answers, everything that I have here is sufficient. You need your candidates test. You have to show y of 0 and y of 6. That would be a point. You'd have to find that t was the 5.1179 as a critical point, and then evaluate it. Like this part alone would probably be about 4 points. So if you don't do the y of 0 and y of 6, you lose a point, okay? All right, questions on that one? All right, let's try another one. This one says, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T. So what I want you to kind of understand is that this G of T is a rate, okay? It's in tons per hour. And T is measured in hours, and T is a closed interval from 0 to 8. At the beginning of the workday, T equals 0. The plant has 500 tons of unprocessed gravel. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So it's coming in. So the G of T is the coming in, and the 100 is the going out. Okay, so there's my rate in and my rate out. So it says find G prime of 5. So you can actually do this on your calculator, okay? Same thing, okay. So what I want you to do you remember how to do a numerical derivative? Open up a blank calculator page, and you're going to do calculus, press menu, calculus, and do derivative at a point. Let me pull mine up and show you how to do it. So here's calculus, and we'll do a numerical derivative. So you're going to do x, and we want this at 5, and we just say okay, and then you just have to type in your function. All right, did you get negative 24.5875? That's what I'm getting here. So, and it says interpret this. So I would say at t equals 5 hours, the rate at which gravel arrives is decreasing. So now I'm telling it that it's a rate of a rate by 24.5875 tons per hour per hour. Do you see that? It's a rate of a rate. All right, I'm going to pause a moment, and I want to see if you can come up with part B based on what we did initially on that first problem. It says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So it's only asking me about arrives. So see if you can set this one up, and then you are going to use a calculator to do this. No, this is just arriving. All right, discuss at your tables. If you feel really confident, share with your table. All right, let's take a look here. If I'm not interested in what's getting processed, I only want to know what's the total amount of unprocessed gravel that arrives during the hours of operation. So you're just going to do the integral from 0 to 8 of g of t dt, and I got 825.551 tons. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Well, let's go figure out G of 5. Well, we have G of t, so you would go pop that in. Because that's a cosine, make sure your mode is radians. You'll be in radian mode on the AP exam. So I got 98.140, and that's tons per hour. This is what's arriving, right? And then what's the output? Isn't it 100 tons per hour?
Oh,
yeah. So then, is the amount of unprocessed gravel increasing or decreasing? All right, so the amount of unprocessed gravel is decreasing at t equals 5 hours since G of 5 is less than 100. All right, letter D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? And justify your answer. So we're going to look back, and do you see that that is a closed interval? So we're going to need to do the extreme value theorem using the candidates test. I'm going to pause a moment, and I want you to try this. You need your endpoints, so that's 0 and 8. And then what else do we need to find to test? The relative maximum, okay? And that will be where G prime of t equals 0. So let me give you a moment to see if you can set that up. Now, something we have not written, and maybe we should do this. If I call U of t my unprocessed gravel, you started with 500 plus, then from 0 to 8, you have this G of t, which is the arrival minus how much gets processed, right? Because you need to know what you're plugging into to do the U of 0 and the U of 8. Then you need u prime of t, which is going to be, well, g of t minus 100, and you want to know when that's 0. So you're going to want to do that one on the calculator, where you plug in g of t, graph it, and graph 100 and look for their intersection. You are going to have to play with your window. You press menu on the graph, and you can change your window settings. Or you could do g of t minus 100 and look for the x-intercept. That might be faster. Did anybody get the t value yet? For the relative maximum? I got 4.923. All right, this is a tough one, okay? This is a tough one. But this is like the level of free response style question that you will see. But kind of some big ideas is that if your function is a rate, then an integral will give you the amount. And then if you want that total amount, it's the initial plus that accumulated difference. Okay, so an integral of the rate in minus your rate out is the big idea. All right, so let's look at this one. This one says posting memes. After the AP Calculus exam, students post memes at a rate of m of t equals 231 sine pi t over 24 for time between 0 and 24, where m is measured in students per hour and t in hours after the AP exam ends. After 12 hours, the College Board begins canceling scores of students posting memes at a rate of c of t. So then that time is between 12 and 24 hours. And c is measured in students per hour and t is in hours. Let s of t be the number of students who have posted memes but have not yet had their scores canceled. After 24 hours, how many students have posted memes? So what would you need to do here to find out how many students have posted memes? What would you do? Yeah, Julia? Of what? Good job. There you go. So this will be a calculator problem. So go ahead and compute that. This one does say round to the nearest whole number. Yeah, I don't think they want us to have a partial, like fingers and toes. That's funny. But what's interesting is in some problems, like they do it, and I was like, that doesn't even make any sense. I'm not part of a person or part of a bee, or you know what I mean? Like come on. All right, discuss at your tables. Did you get the same number? I want to make sure you know how to do this on your calculators. All right, I heard multiple tables. 3,529 students. Okay, nice job. Part B. At time is 19. Is S of t getting larger or smaller? Okay, well, S of t is 0 to t of, and I'm going to just change the variable for, if this is time 0 to 12, but S of t is going to be from 0 to t m of x dx minus 12 to t c of x dx for the time 12 to 24. So they're asking us for a rate, right? So if I want s prime of t, that's going to be m of t minus c of t. At t equals 19, s prime of 19 would equal m of 19 minus c of 19. Well, we have functions, don't we, for m and for c. So go ahead and use your calculators and figure out what m of 19 is, go figure out c of 19, and then subtract them to figure out what s prime of 19 is, because when it's saying, is s of t getting larger or smaller, I want to know, is that derivative positive or negative? Because where the derivative is positive, it's increasing. Where the derivative is negative, it's decreasing. I got negative 19.425. So I would say, since s prime of t is less than 0, s of t is getting smaller at t equals 19. All right, part C. At what time is the number of students that have posted memes but have not yet had their scores canceled a maximum? How many students have posted memes but have not yet had their scores canceled at that time? Rounded to the nearest whole number. So we know we're going to need to do the endpoints. That's s of 0 and s of 25. But then we need to find the times when s prime of t equals 0. And since that's m of t minus c of t, you want to set m of t equals c of t. Now, because we're running low on time, I already did this and I found two values. And again, because of time, I already did the computations. And then here's how I would write that out.